So we were quite, and not only we, but I think the recyclability of thermosets really caused a disgrace to the polymer sustainability. So we all know that thermoplastic polymers can be recycled. You heat and you reprocess them, whereas thermoset plastics, due to their three-dimensional network, cannot be reprocessed, cannot be reshaped by applying heat. And so what happens is that they end up either in the landfill or at the best they will be incinerated for getting some energy. So in my group, we thought about if there are not any other ways to recycle the thermoset scrap. And we came up with an idea of looking at the possibility of converting thermoset materials with a three-dimensional permanent network into Vitrimers, which are material which have a dynamic network. And the meaning of that is that when apply a stimulus like heat or light or a change in pH, you can make that dynamic network to accessible, let's say, for changing the topology of the polymer and making the polymer reprocessable by conventional processing techniques used in thermoplastics. So the idea was, why can't we actually look at the thermoset and change the thermoset into a Vitrimer rather than going the traditional way of synthesizing a Vitrimer from the monomers from scrap, so to speak. So we first use that vitrimerization, or the concept of vitrimerization, by infusing into the thermoset network solution of the catalyst, which will enable the transesterification reaction, which is that reaction to actually make the network dynamic. In other words, make it make possible the reprocessing of the material of the system. And so initially we use the catalyst in a solvent to infuse the thermoset and then try to reprocess it. However, we found out from industry that solvent is not really something which is very much liked in industrial settings. And so we came up with the idea of why not try a mechanochemical approach to convert the thermoset into a Vitrimer. And so with that in mind, we took the thermoset scrap, grind it, and then ball mill it with the appropriate catalyst in order to make possible the ligand formation, the metal from the catalyst, the metal ester ligand formation in, let's say, an epoxy resin. And then once we do that, we can take that very fine powder and apply either compression molding or injection molding to reshape it. And we were successful with that. And so what we did then, we applied that same rationale in developing technologies for converting not only epoxy, which was the first material we tried, but also thermoset polyurethane, thermoset carbonates, thermoset cross-linked EVA into Vitrimers. And so we expanded the use of this technology to a larger class of thermoset materials. and more recently also to composite materials. And so this is sort of the Vitrimerization 101, in which we try to apply a new technology to convert thermoset scrap into a useful material, having in mind or keeping in mind sort of a spiral economy.